let's take a look at solving. So let's look at the bottom. So we'll skip the calculator directions for now. So solve equation using nth roots is very similar to solving square roots. So to solve an equation of the form u to the n equals d, where u is an algebraic expression, you're going to take the nth root of each side. So for example, if you have x to the fifth, you're going to take the fifth root. If you see x cubed to 27, you're going to take the cubed root. If you see x minus 2 squared equals 15, then you take the square root, right? So what we want to do is isolate, and we used to isolate the squared. We're isolating whatever let's just say the nth power, because we don't know what the power is. So for now, I'm just going to call it that. So we want to isolate this x to the fifth first of all. So how do we do that? Well, we're going to divide by 4. So let's divide by 4 first. And so now we have x to the fifth equals 4 goes into 12, 32 times. Now in order to get rid of that fifth power, we don't do the square root. That's not enough. We have to do the fifth root. Okay, so that's what it means by nth root. We're taking the fifth root of both sides. So now that cancels out that exponent of 5. And so now we have x equals, what's the fifth root of 32? That's 2. Okay, so just using that to solve. Let's take a look at B. So that fourth power is isolated, right? This raised to the fourth power is isolated. Now you don't want to distribute or multiply this out. Now if you remember, in order to multiply this out, you would probably need to use Pascal's triangle, right? And so that's a lot of work, and there's not a lot of space here, so that's not what we're supposed to do. So what we want to do is we want to get rid of that fourth power, and what we do is we take the fourth root of each side. So now what that becomes is x minus 3 equals, fourth root is even, so therefore it's plus or minus square root of 21. Then to finish solving for x, we're going to add 3. So x equals 3 plus or minus the square root of, the fourth root of 21. Oh, don't forget the fourth root there. So it's very important to write that, or you do change the answer. Okay, and so later on we could evaluate that with a calculator. So 3 plus the fourth root of 21 and 3 minus the fourth root of 21. So try out these 4 examples, please. And you could leave it like that. You don't need to evaluate with a calculator for now. See if you can try these out. All right, if you tried this out, number 13, you would get x equals 2. You divide by 8 first, then take the cube root of both sides. Number 14, in order to get rid of the fraction, you multiply by the reciprocal. So we're multiplying by 2 to both sides, and therefore you have x to the fifth equals 1,024. Now 1,024, I tried 4 because there's a divisibility rule. So there's several divisibility rules on just depending on the number that you're trying to find. Now, if 4 is divisible into the last 2 digits of whatever number you see, then it is divisible into the entire number. So because of that, I did 4, and then, that I tried it. Okay, well, 4 goes into it, so I tried 4 times 4 times 4 times 4, whatever it is, 4 or 5 times, and then I found that I would get 1,024. So the final answer here is 4. Number 15. You take the fourth root of both sides right away. Remember that it's a even index, so therefore it's plus or minus 2. So then you solve, so you get x equals negative 5 plus 2, which is negative 3, and x equals negative 5 minus 2, which is negative 7. Number 16, you have cube root of x minus 2 cubed equals cube root of negative 14. And so you would just keep it the same. So remember, we get one real nth root, so it's just cube root of negative 14. I'll leave it just like that. So our final answer is x equals 2 plus the cube root of negative 14. So we're going to learn how to use a calculator. So let's do some examples above. So we're going to approximate expressions with rational exponents. It helps to know how to rewrite these back and forth. So the nth root of a, we can write it as the nth root of a, or remember, we can write it a raised to the 1 over n. So we need to be able to go back and forth. Remember, n is the index. A is our radicand. So we're going to approximate expressions using a calculator. So if you have a calculator, I call it my grade calculator in class. It's more of your scientific calculator, just like it is in your like your cell phone, like if you turn it sideways for an iPhone, you have that option, all the other options. So how you can plug this in is that we have 9 raised to the 1/5. So you type in 9 and then you press the y to the x button because you're getting to the exponent. Okay, y to the x, and on your cell phone it might be x to the y. I know on my cell phone it says that. So you get 9, press the y to the x, and then you do parentheses 1 divided by 5, close parentheses, and then when you do that, you're going to get like 0.2, and then you press equals, and then it takes that exponent. Okay, then when you do that, you would get 1.55. And so for my pink calculator, if you remember my pink calculator, the TI-30X2S, it's very similar actually. You just press 9 and then there's a caret. Okay, it's a caret. It looks like this. And then you type in the same things. Parentheses 1 divided by 5, close parentheses, and then equals, and that'll get you the same answer. Now there's one more way that you can solve for this. Now in the pink calculator, it's nice. On the pink calculator, you might see something, it's above the caret, and it's also on the gray calculator. You see X and then this. So that is our index. So if you wanted to use that, we could rewrite this 9 as 5th root of 9, and that's our index. Now if you wanted to use it in that form, just as an FYI, you would have to type the 5 first, then you type in second, you press second, that caret button, and then you press 9 and then enter, and that will give you the same answer. Okay, so it just depends on how you see it, and you can try either way, whatever you are most comfortable with, whatever you will memorize when you are doing the test. Now for the rest of these, I would probably just use it in this form here. So if you don't see it in fraction form, then rewrite it in fraction form. So for example, letter B, you would type in 12, and then either the y to the x in the gray calculator or the caret button in the other calculator, parentheses 3 divided by 8, close parentheses, and then equals. Okay, and that's how you would do that. Letter C, so let's rewrite that. 4th root of 7. So the 4th root tells me that goes in the denominator place. Okay, so the index goes in the denominator. And then so plug that in the calculator. So try out B, C, 9, and 10. Number 11, you could actually do that without a calculator. So let's do that one. 16 to the 1/4. And then to the 5th power. So that's 4th root of 16 to the 5th power. So that becomes 2 to the 5th power, which is 32, okay? But please learn how to do the calculator with that. So B, C, 9, and 10. All right, if you tried this out, you should have gotten approximately 4.30 for C. For this one, you would get approximately 2.54. For number 9, you'd get approximately 2.05. For number 10, you would get approximately 0.06. Now for this one with the negative, there is a negative button for the pink calculator. It's all the way at the bottom right corner next to the enter sign. It looks like this, and then right above it has ANS. So that button, that's actually the negative button. Don't press the subtraction button that's between the X and the plus, right? Because that'll tell you if there's an error in how you plugged it in, just as an FYI.